Look at a long-term climate projection, and the lines resemble a frayed rope. These pathways represent specific, scientifically modeled versions of our planet. I'm Dr. Mari Muthu. Today, we are analyzing the global climate system. We will track 3 distinct trajectories across 5 multi-decadal horizons to see where these paths lead. These climate stripes visualize our history. The shift from cool blue to recent deep reds shows the warming we've already realized. From this thermal baseline, multiple pathways branch out. We are moving toward a green, amber, or red future. We will map the physical impacts and the socioeconomic realities of the best, neutral, and worst-case scenarios over the next century. Shared Socioeconomic Pathways, or SSPs, provide the structural foundation for this analysis. These narratives explore possible futures based on energy consumption, land use, and mitigation strategies. These models are governed by radiative forcing. This is the net change in the Earth's energy balance, measured in watts per square meter. It quantifies how much energy our atmosphere traps by the year 2100. We are tracking 3 specific trajectories: SSP 1-1.9, the best case, SSP 2-4.5, the neutral case, and SSP 5-8.5, the worst case. Human inputs, energy choices, technology, and land management dictate which mathematical pathway becomes a physical reality. Because these scenarios are scientific boundary conditions driven by human activity, the timeline reveals the direct consequences of our present decisions. We begin at 2031. For the remainder of this analysis, we will track all 3 lanes simultaneously. Global surface temperatures are nearing a lock-in. Across all 3 scenarios, the 12-month and 132-month running means cross the 1.5 degrees Celsius target. Roughly 9 centimeters of sea level rise is now unavoidable. In 2031, the divergence is socioeconomic. The best case features a rapid shift to solar and global tech cooperation. In the neutral case, erratic weather becomes a management challenge for cities and farmers. The worst-case baseline is defined by economic disruption. Deep recessions and climate-induced stress begin to strain the global middle class. At this near-term horizon, physical climate impacts are nearly identical. The trajectories have not yet physically separated. By 2036, the signal emerges. Events once considered unprecedented become the new climatological baseline. In the best case, global emissions peak. As warming slows, green technology industries successfully replace fossil fuel roles in the global economy. The neutral case follows stagnant emission levels. Heat waves are now 3 times more likely than in the pre-industrial era, contributing to widespread digital fatigue. The worst-case trajectory sees unchecked emissions growth. Summer Arctic sea ice is now dangerously thin, and extreme economic inequality becomes a permanent societal fixture. 2036 marks the point where the delayed physical consequences of the previous decade begin to pull the 3 trajectories apart. At mid-century, we reach a physical splintering point. Cryospheric feedbacks begin, and the economic costs of coastal inundation and agricultural failure scale exponentially. The best case achieves net zero CO2. Warming peaks at 1.6 degrees, and circular economies stabilize global growth. In the neutral case, temperatures reach 2.0 degrees. The Arctic is now ice-free in September, and populations increasingly rely on indoor environments to escape extreme heat. The worst case presents a catastrophic failure of the Arctic system. Temperatures in this scenario hit 2.4 degrees, triggering a 50% loss of permafrost. As this releases massive carbon reserves, the sheer scale of the crisis outpaces international governance, leading to a collapse of global orders. Mid-century is the transition from climate mitigation to a focus on desperate endurance for any pathway above SSP 1.9. By 2076, the mathematical divergence is irreversible. The best case shows stabilization at 1.4 degrees. This allows coral reefs to begin recovery and supports a highly automated, stable society. In the neutral case, temperatures hit 2.5 degrees. This triggers the dieback of the Amazon rainforest, crossing a critical biospheric tipping point. The worst case reaches 3.5 degrees of warming. Ocean pH drops to 7.8, creating a highly acidic environment that threatens the foundation of marine life. Hothouse Earth conditions force billions of climate refugees to migrate. As fertile land disappears, competition for resources shifts from diplomacy to localized conflict and warlordism. In the neutral and worst-case scenarios, the Earth system's self-amplifying feedbacks have overtaken human agency. The 22nd century is a legacy of the 21st. Our current energy choices determine the planetary baseline for the next 100 years. The best case reflects a world restored. Sea level rise is limited to 0.5 meters, and the climate begins returning to 1900 level baselines. The neutral case shows continued deterioration. Sea level rise reaches 0.9 meters, and the Atlantic meridional overturning circulation is significantly weakened, altering global weather. The worst case reveals a world defined by rising seas and a hostile exterior. Sea levels exceed 1.3 meters, forcing humanity into indoor megahabitats and high-stakes geoengineering. The climate of the next century is a direct commitment to sea level rise and permafrost release established decades earlier. Viewing the entire 100-year trajectory reveals a system in profound transition. The data gap between stabilization and exponential warming is massive. Every fraction of a degree of warming avoided before 2051 reduces the probability of triggering the irreversible tipping points of the 2070s. We have analyzed the physical realities of the SSP trajectories and the critical mid-century points where these paths splinter. Present-day policy and emission decisions are the active variables calculating our trajectory for the next century. I'm Dr. Marimuthu. For more rigorous analysis of complex systems, stay with Bodhi Unified Flow. All IPCC and systemic risk data